Alrighty guys, here is another tutorial video, aka just like the notes you would do in class. So we're on to topic 6 if you have your booklet. If you don't have your booklet at home, just follow along, jot down the notes so you have something so you don't have to refer back to the video all the time. Okay, here we go. So topic 6, we're looking at polynomials now that have some sort of value for x squared, a coefficient. Remember, this is a coefficient, anything that's multiplying by that number. And so we want to look at these, and basically we're doing the same thing as we did when we didn't have a coefficient there, but let's take a look at what it looks like anyways. Okay, so just so we can refer back to multiplying polynomials, the same things, our distributive property still follows. 3d times 4d is 12d squared. 3d times 2 is 6d. And if we follow that, oh, sorry, that's not 8, that's 16d. And that times that. Oh, there's the bell. Did you miss the bell? 4 times 2 is 8. We add that together, 12d squared plus 22d plus 8. Right? So we know how to do that. I'm not going to spend a lot of time on that because we've already been there. I want to move forward on factoring. And there's a couple of things here. If you haven't mastered the factoring we've already done, that's okay. You can move on to this. Just be aware you might be missing a few pieces of it along the way. So here in example 2, what you want to still be conscious of is that there might be a common factor for all 3 values. So if we think about this and look for 4, and you might have to divide this by 4 and double check, but it's a good thing to check. First of all, is check for a common factor. If you have a common factor, you might save yourself a little bit of work. So since in this case we have a common factor of 4, it doesn't matter if you use -4 or +4, just be leery of how you do the signs. Okay, so I'm going to go ahead and I'm going to take out -4. So that would leave t squared there. It would leave +4 here, because -4 times +4 would make -16. And to get this to be a positive, I'm going to have a negative number, and it turns out that is 32. So once I have it boiled down to a regular trinomial, no coefficient here, just like we dealt with, we're going to kind of ignore that -4 for a second and go ahead and do what we did before. 1 times -32. We need 2 numbers that multiply to get -32 and add to get 4. If it doesn't immediately come to you, that's okay. Write down factors. 1 times 32. 2 times 18. Not divisible by 3, so we're going to jump to 4. 4 times 8. Okay? You can see right away there, hopefully, that you can create +4 out of that. So we want +4, so we need the bigger factor to be positive and the smaller factor to be our negative factor. And that will make sure that we have a -32 at the top. So once we have that, we go ahead and do our factoring. Except for now, we're going to have this extra common factor on the outside. We can create our binomials though. So we have t plus 8 and t minus 4. So if you went ahead and did that, you'd see -4, you'd go ahead and do these, t squared, t times -4 is -4t, plus 8t minus 32, and we'd have -4t squared plus 4t minus 32, which is what we have there. And we could go further, multiply this in to go back to our original polynomial. And therefore we know we're correct. Remember, you can always check these factoring questions. I'm going to just quickly pull out the 5 here, and then I want to move it along to the next stuff so we don't get too long of a video here. But you can see there's a common factor of these 3 of -5. So you'd be left with h squared plus 4h and minus 12. And you could go ahead and factor out this. Okay, moving right along. So this is where things get slightly trickier. You first of all take a look for that common factor, and you can see 3, 13, and 10. It has to be a common factor to all 3 terms. Does not have a common factor, right? So given that these are both prime numbers, it's unlikely you can't get a common factor. So instead, we're still looking at our x, and we're still looking at this times this, only now it's not 1. So we multiply these, 3 times -10, and that goes in the top here. And this bottom number, or sorry, middle coefficient, sometimes we call that b, is still going into the bottom of our x. So this step is the same. We still need factors. Sorry, this is so bouncy, this silly stand. It's kind of shaky. We're still looking for factors that multiply to get this and add to get our bottom value. So we can go through those 1, 30, and we'll adjust for our negatives in a second. 2, 15. Okay, if we start thinking, if we have -15, that'll create our -13 if we add 2 to that. And if we multiply those, that gives us -30. So we can go ahead and jot those in. 2 and -15. This is where things get a little bit different. So you're going to take this first value, you're going to put it over here, okay? Then you're going to look for, out of these 2, which one of them can kind of are related, are multiples, factors that would be related. And 15 can be related to 3 because you can multiply 3 to get 15. So that's going to go in this next spot. Okay, and what we're doing is we're breaking down this inside. We call it decomposition. Then we have our 2s. So we've broken down that -13s into 15 and 2 by taking it from our factors over from our big x thing over here. And then our -10 goes out here. So we put that into 2 binomials, and we look for the greatest common factor out of those. So what is the greatest common factor in here? Well, you can divide them both by 3, so we can pull out that 3. And when we look at our variables, the greatest common factor for the variable s is, we have s squared and s, so the lowest one is just s. Then we look at here, same thing. What's our greatest common factor here? Well, it is 2. This time we can't use an s because there's not s in both of them, so it's just going to be 2. Now, write those again and look at what's left when we do that. What's left of this 3s squared minus 15s when we pull 3s out of it, when we divide it by 3s, just like we've done in the past. Sorry, this is shaky. So what do we have left here? Well, from 3s squared, it's just s, right? 3s times s would give us 3s squared. And of our -15s, it's -5s. Nope, sorry, not s, because we have our s there. Out of here, when we divide by 2, what's left inside is 2 times s, that's s, and to get -10, we have to multiply that by 5. Voila! This is the important part. These 2, when you pull out the greatest common factor, exactly the same. So, what are our two binomials that we're left with that could be multiplied to get back to our original trinomial? We have this one and this one together. That makes one of our binomials. So 3s plus 2. And then we take that exact same one. And that's s minus 5. And if you think about it, that's what we do, right? When we rainbow in, we're going 3s times s minus 5 and 2 times s minus 5, right? That's just how that's broken apart or decomposed. So these are our two binomials. And that, if you multiply it out, you will get back to your original trinomial. I'm going to do one more, just checking. I'm going to do this one, and you can check your understanding on A, but I'm going to do this one for you as one more example. Okay, in this case, first of all, we're looking for a greatest common factor in all three of our coefficients and constant, and that greatest common factor is 4. So I'm going to go ahead and pull out 4, but what I'm left with, 24 divided by 4, is 6h squared, negative 5h minus 6. So what I'm left with, this time I still have a coefficient on my h squared, so I still need to do that other process. Okay, so I'm looking for my top number, which is 6 times negative 6, negative 36. That's a times c. Okay, if we call this a, b, c. And at the bottom, it's b. Now, what are our factors for that? For 36, 1 and 36, 2 and 18. No, that's not going to add together to get negative 5. 3 and 12. There's no getting negative 5 out of that. How about 4 and 9? Well, if I have negative 9 plus 4, I can get negative 5. Again, we need the bigger number to be negative so that this bottom number is negative, and we add the 4 to that to get negative 5. Okay, leave that 4 behind for a second, and let's just focus on this. So we're going to decompose this, our 5h, by splitting this off, 6h squared, and we've got to use our two factors now. So I'm going to put the 4 in here. And plus 4h, and I'm splitting that into 2. Then I have negative 9h and negative 6. Okay, so what's the greatest common factor in each of these binomials? The greatest common factor here, they're both divisible by 2, and there's an h for both. So what's left? How can I get back to 6h squared? 6h squared divided by 2h, 3h. 4h divided by 2h is plus 2. Hopefully that's what I land up with over here. What's the greatest common factor of negative 9 and negative 6? Negative 3. And watch those signs. Here, what do we have left? 3h. Negative 6 divided by negative 3, also plus 2. So we can go ahead and boil down our binomials into 2h minus 3 multiplied by that common one, 3h plus 2. And don't forget about that 4 that we took out way at the beginning. It's going to come down there. And that's your final answer. Okay, so I will post the assignment for this in the classroom, and email me, check out Google Hangouts, and ask me questions there if you have any. Just make sure you're staying in contact with me. I really want to help you through this really weird time. Hope you're all well. Talk to you soon. Bye-bye.